My dear students, today in this third lecture of the solids or mechanical properties of solids, as I told you, we will see some numericals based on Young's modulus and Hooke's law, right? So in the previous lecture, we have discussed a lot many theory. In the first video, I started with deforming force, elasticity, intermolecular forces, and all those stories, and later on I completed what? The stress, types of stress, strains, types of strains, and then Hooke's law, right? Now, and different types of modulus of elasticity also. In that, one type of modulus of elasticity, that is Hooke's. Based on that, whatever questions will be there, that we are going to solve. Okay, no problem. So briefly I will revise. What is the Hooke's law? Hooke's law says stress is directly proportional to strain, and from that we are getting what? Stress is equal to E into this strain, and this modulus of elasticity we are getting as a stress by strain. Okay, now so if this stress is a direct stress, that is force is perpendicular, then or normal stress, normal strain, then we can say it is a Young's modulus. Okay, if this is the direct stress, in that case we can replace this modulus of elasticity with the Young's modulus. That mainly happens in the solid, as I told you. Right? Now look, modify this equation. Stress is what? Force, perpendicular force divided by area, and the strain is what? Change in length divided by original length. Okay, so here if you modify this, FL divided by A into delta L. Okay, so this formula you must remember. What we have to remember? This formula you have to remember. Young's modulus is equal to load, that is force, length, original length, cross sectional area, and a delta L, change in length. Okay, or this also you can modify like this. Delta L, if somebody asks you to calculate delta L you will take on this side, Young's modulus on this side. So FL divided by A into Young's modulus. So this formula also you can remember. If they are asking this all data they will give. Sometimes they will ask this data they will give. So whatever may be, this formula we have to use. Okay, so let us start some numericals. Note this formula, these two formula you can note, and so this is one example. The following four wires are made up of same material. Which of these will have the largest extension? What they are asking? Largest extension means delta L they are asking. When the same tension is applied, same force, under application of same force. So what is the formula? Delta L is equal to FL divided by A into Young's modulus. Barabar? So same material is there. So Young's modulus will be same, force is same. So only what remains? This we can write FL divided by diameter they are asking means cross section is a what? Cross section is circular. So pi by 4 d square is the area into Young's modulus. Right? So in this force pi by 4 and y are same for all. So if you will compare, so that will be cancelled. So basically here this delta L is directly proportional to what? L divided by d square. So you check L by d square for every option and you will get the answer. So let us check for this first option. Let us check delta L1. You can say L is what? 200 divided by d is what? 2 square. So this will be basically this is what? Millimeter. 1 unit should be there, no? Either you do calculation in centimeter or millimeter or meter. What do you want? You complete this calculation. So 200 into 10 raised to minus 2, and this 2 into 10 raised to minus 3, it's square. Okay, so 200 into 10 raised to minus 2 divided by 2 square 4 into 10 raised to minus 6. So what you are getting? This plus 2 minus 2 cancel. So this is 1 by 2. So this is what? Delta L1 is equal to 0.5 into 10 raised to, what you will get? So this plus 2 minus 2 cancel. So plus 6. Okay. So 0.5 into 10 raised to plus 6 we are getting. Now what about for this you calculate? Delta L1 2. Delta L2 is what? 300 into 10 raised to minus 2 divided by 3 square 9 or 3 into 10 raised to minus 3 its square. So is equal to 300 into 10 raised to minus 2 divided by 9 into 10 raised to minus 6. Okay, so this is cancelled. So 3 ones are 3. So 1 by 3 into 10 raised to minus 6. Okay, so this is half. This is 0.33. So delta L2 is equal to what? 0.33 into 10 raised to plus 6. 10 raised to plus 6. Okay. Then for third one, for this you do the calculation. Delta L3 is equal to what? 50 into 10 raised to minus 2 divided by 0.5 into 10 raised to minus 3 its square. So this will be what? Basically 50 into 10 raised to minus 2 divided by 0.5 means 1 by 2. 1 by 2 square. 1 by 4, and that 4 will go here. Are you getting? Do the calculation. And into 10 raised to minus 6. So this will be 200 into 10 raised to minus 2 into 10 raised to 6. So this 2 and this 2 get cancelled. So this will be 2 into 10 raised to 6. Okay. So out of these 3 we are getting largest. So this is 0.5 only. This is 0.3 and this is 2. Okay. Here for this you check. See the same way. Delta L4 is equal to what? 100 into 10 raised to minus 2 means this will become 1 divided by 1 into 10 raised to minus 3 its square. So this will be, so this 2 get cancelled. So 10 raised to minus 6 and this will be 10 raised to 6. So 1 into 10 raised to 6 you will get. 1, 2 and these are again very small. So largest they are asking. So which is the largest? Third option. So this combination will give you the largest elongation or extension in the material. Is that clear? Okay. So question number 2. The ratio of diameter, length and Young's modulus of steel and copper wire are given. Means P is what? P is given. P is what? Ratio of diameter. Diameter of steel. P is what? P is diameter of steel to the diameter of copper. Then Q is what? Ratio of length. So length of steel to the length of copper. And S is what? Young's modulus. Young's modulus of steel, Young's modulus of copper. This is what given. Then the ratio corresponding to their increase in their lengths would be. So delta L of first is what? First is steel. Steel to the copper. Steel to the copper we have to calculate. So what will be the formula for this? Formula for this will be what? FL A into Young's modulus for the steel. Then FL A into Young's modulus for the copper. Arrange this. So delta LS, delta LC is equal to what you can write? Force of steel into L of steel divided by A of steel into Young's modulus of steel into, this will go up, area of copper, Y of copper, force of copper and a L of copper. Okay, so this you will get, this ratio is given. So force Fs by Fc force, then LL, LS by LC, LS by LC, then AC, AC by AS into YC by YS. Okay, so these three parameters are given here. Only this is remaining. This is what? Tension basically. Fs means what? Tension on the steel. Here, this tension. This is what Fs. Okay, and Fc is what? Fc is tension here. Tension. Fc. So this tension is what? In laws of motion we have learned. Tension here will be what? Mg will act here. 5 mg will act in the downward direction. And this is equal to tension. So T, Fc is equal to what? 5 mg. Fc is equal to what? 5 mg. This is Fc. And Fs is what? 2 plus 5, 7 mg. 7 mg will act here. And that is equal to this T. Means Fs is equal to what? 7 mg. 7 mg into Ls by Lc. Ls by Lc is Q. AC by AS. AC by AS. So this is not given, but diameter is given. So what you can write here? Pi by 4 dc square divided by pi by 4 ds square into yc by ys is given. Ys by yc given. Here yc by ys is there. So opposite 1 by s. So this is what? 1 by s. This parameter 1 by s. This parameter q. This parameter is this. This, for this we have written this pi by 4 get cancelled. So this dc by ds. So this opposite 1 by p. dc by ds is square. But here ds by dc is given. But dc by ds means what? 1 by p. So 1 by p square. So this mg cancel. 7 by 5 into q into this is what? 1 by p square. 1 by p square into this 1 by s. So basically what you are getting there? 7q divided by 5 s p square. 5 s p square. Check this option. Where is it? 7q 5 s p square. So option B is the answer. Got it? Simple. Little lengthy, but simple question, right? This was asked in 2013. This was asked in 2013. NEET medical exam, right? Okay, note it first. So now 2015 question number 3 of today's lecture. The Young's modulus of steel is twice that of brass. Okay, Young's modulus of steel is twice that of brass. Two wires of the same length, same area of cross section, one of steel and another of brass are suspended from a ceiling. One is of brass, one is made up of brass, this wire, brass wire, and another is made up of steel. Let us say this is steel. Steel and brass are suspended from the same roof. Okay. If you want the lower end of the wire to be at the same level, means this level or this level we can say same. If you want, means what? Means what happens? Due to this weight, what happens? Let us say this is the weight on the brass wire and this is the weight on the what we can say steel wire. Means mg, mass of this mass and this mass. So weight we will say into g. So this will come down, this will come down. Okay, and after coming down, they will settle at the same level they want. Means what? Extension in this and extension in this will be same. Then only they will be on the same level. Correct or not? So delta L of brass is equal to delta L of steel. What is the formula then? Force. Force is what? This is the force. So WB. Force is basically tension, but tension is equal to the same load, na? So this W will act here and tension will be here. So tension is equal to what? Force on this will be tension. So tension is equal to what? WB. So WB FL, length of brass, FL by A, cross section area of the brass, into Young's modulus of the brass, is equal to weight, same here, tension here, this WS here. So this tension is equal to what? WS. So load here is what? Or F here is what? WS, weight of the steel, into length of the steel, area of the steel, Young's modulus of the steel. Okay, this we can write because this is given, right? So what they want then? Then the weights added to the steel in the ratio. So this ratio we have to calculate. This by this ratio. First is what? Steel. To the steel to the brass. Steel first. So this W you take on this side. Or you calculate this, then we will do this. W, yes, I will take here, and remaining things on that side. So WS we are taking here, then LB here, AB, area B, area S here, this will go here, this by this, area, then length LS, this will be here, then Young's modulus here. Okay, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 parameters. So this we want. We'll do this reciprocal ladder. AB by AS is how much? This ratio is given. From this you will get YS by YB is equal to YS by YB is equal to 2 by 1. YS by YB. So opposite 1 by 2. This is 1 by 2. Same length they are asking. Same length and same area of cross section. So area of cross section same, length same. So only this will happen. YS by YB, YB by YS. So this is 2 by 1. So 1 by 2. Simply. So what you are getting? So reverse of this, steel brass. So WS steel, WB brass. These are the weight added. So 2:1. Simply 2:1. Option D is the answer. Simple question. Okay. Note it fast. So question number 4, 2018 NEET 2018. 2 wires of made up of same material. Same material means what? Young's modulus same. Remember, same material. Young's modulus same. 1, 2. Same Young's modulus. Right? Then first wire has a cross section area A and second wire has a cross section area 3A. A1 is equal to A, A2 is equal to 3A. If the length of the first wire is increased by delta L by applying a force F, how much the force is needed to stretch the second wire? Okay, F1 is equal to F, F2 is equal to what they are asking. Okay, and delta L should be same, they are asking. Delta L1 is equal to delta L2. Same stretching should happen. So delta L1 is equal to delta L2 they are given. So FL divided by area into Young's modulus of wire 1 is equal to FL into area into Young's modulus of wire 2. Correct or not? Here this Young's modulus same, y1 y2 same, so that will get cancelled. Then this area you can put and you can see. Then what about length? L1 and L2 is there? No. Okay, so how to calculate this L1 and L2? Initial same volume is there. Same material matlab means this. And the same volume means what? V1. So let us say so this we will write F L1 divided by area A1 is A is equal to F, we have to calculate, that is F dash of F2 you say. F1 is F F2 we have to calculate. L we don't know. Okay, area A2, this will be A2. A2 is how much? 3A. Okay, so what about L1 and L2? That is the question. This area will get cancelled. So L1 and L2. So for that, what we need to do? This F2 we want to know. So F divided by L1, this L2 will come here, this 3 will go here. 3F L1 divided by L2 is equal to F2. So F2 we are getting, but this L1 and L2 we have to cancel, because in this here there is no L. So we need to find out the relation between these two. So for that purpose, what we can do? Same volume is given, no? So V1 is equal to V2. So how to calculate volume? Area into length. So A1 L1 is equal to A2 L2. So L1 by L2, L1 by L2, L1 by L2 is equal to A2 by A1. So L1 by L2 is equal to A2 is how much? A2 is 3A and A1 is how much? A. So A get cancelled. So L1 by L2 is equal to 3. You put here. So 3F into 3 is equal to F2. So F2 is equal to what? 9F. So this is the answer. Got it? So NEET 2020 question, Corona period, right? So wire of length L1, wire of length L1, let us say this is L1 wire, okay, hanging from fixed support. The length of the wire changes to L1. Initial length was L1, now this is L2. This is a L1. Initial length is what? L. Initial length is L. And new length is L1. Initial length is L and new length is L1. So due to this mass, some mass will be attached here, and due to this mass what will happen? It will apply force on this side mg. Tension will be there. Due to this tension what will happen? This wire will be stretched downward, so it will come here. Okay, so new length is what? L1. So delta L is what? Delta L is new length L1 minus original length. Correct or not? Now they are asking what? Expression for Young's modulus. So Young's modulus is what? Force, original length, cross sectional area into change in length. So force is what? mg. Tension basically, but tension is equal to mg. That we know. Into L divided by area into delta L is what? L1 minus L. So where is the option? Check. mgl divided by A into L1 minus L. So option D is the answer. Okay. So 4-5 questions we have solved. I hope you have got the basic idea how to use the formula, this basic formula. Okay, and to calculate different things. Sometimes ratio will be there, sometimes direct question will be there, sometimes delta L they are asking, sometimes this they are asking. Most of the things they are keeping constant. So most of the time by taking ratio things are getting cancelled. Sometimes ratio based question they are asking. Okay, sometimes delta extension will be same. So I think we have got a good exposure of questions based on Young's modulus. Okay, so these were the previous questions. You just understand, solve again and again. Some additional questions also you can practice from your modules and practice the question. Okay, so in the next video we'll see some questions on the remaining topics, and some topics are also pending, so that also I will cover. Okay, so like, share and comment so that I will get the motivation to create the videos. Right, thank you.